Hello, hi, welcome to my little workshop here. I have a PLC that I designed, and I wanted to give you a little bit of rundown of it. Arduino Mega 2560, and I'm running Open PLC software on it, which I'm using right here. Open PLC. This is the circuit board. So there's the motherboard is this part in here where this is all the motherboard. This is the power supply for the different voltages that are needed for the microcontroller, and it has a real-time clock system built into it, so you can see kind of how that works. Then I have different I/O cards that have screws, 4 of them at each corner. So this card right here is a 12.24 volt AC DC input card, and what I did with this is I have a DC power supply, AC power supply, 24 volts, and then I have a switch to go from either AC or DC. So right now the card is running on DC, and right here these buttons just happen to be the buttons that are right now part of that, so I can go into manual, reset it, I'll go into auto, let's reset it. You can see that the I/O buttons are working. There's the reset, flashing off and on. Now I can come over here and flip it to AC, and now it's an AC, and I'm going to hit the reset button again, and you can see that it still accepts the input being AC or DC. So now these inputs are AC. So let's just go back to DC. I have a light showing that it's on AC and DC, so now the circuit's on AC, and then I have, or on DC, and then here we have the 12.5 to 24 volt syncing input card, what you see here. And then down in the bottom I have the 12.24 volt MOSFET output. As you can see, all the MOSFETs on the board. So that's running all the lights that you see on the bottom. And then the last card is the 120 volt AC output card. It has also 12 points. All of the cards have 12 points. So basically I'm just running a sequence of lights, like a traffic light, and they're not in the right order at this moment, and I decided to do it after I put the lights in, just to kind of show it off, but they need to be placed in the right order yet. And here I have some analog devices where I can adjust the voltage as I increase or decrease this. You can see it changes the voltage. So my analog is on the motherboard, which is this back here. And you see there's a 1 analog input from that potentiometer down there. That's the input that it's using. And then down in the bottom here is the all the of course outputs for the analog. And I'm using 2 of the channels right now that are going to the 2 displays. This one's just a random counting up, stepping up the voltage as it goes. It's 8, 9, 99, and then 1 volt, and it continues up to the 10 volts. And again, this one is adjusted by adjusting this to 0 or all the way to 10 volts. And anyway, you can see that that adjusts that way. Then I've got various buttons I can program in to test it. And you can see here, if I adjust this, I've got some parameters set that turns on the different lights. for depending on the voltage. Now, and down here I have a little setup with a couple of cylinders, and it just pushes the block back and forth to show that it works. So I can go ahead and put this into manual, and I can go ahead and press the button here. Let's see if we can get both of them in here. And it advances it, and it shows you that it's advancing. And then I can return it. Show you it's returning. Same way with the A and B. Advance, return, and that's how basically that works. So now I can hit reset, put it into automatic mode, and you can't go into manual, of course, if you're in auto. Same way if I reset and go into manual, can't go into auto unless I'm done with the cycle or out of manual. So let's go back out of manual, go back into auto. And then we're going to start the cycle. It just shows that the PLC is doing the work. It's pushing the block back and forth, just as a little test. Solenoid valve body here to operate it. Back up a little bit so you can see it. Flow controls to just show the speed of changing it. The proximity switches that they're going on and off depending on the position. And then up here you can see the outputs that are controlling this. And then some of the input cards for the limit switches. And these are some extra cards that I built. I have a relay card here, and up above I have a 120 volt input card. And then above that, this is a 24 volt or 5 to 24 volt sourcing input card, where this one on the board right now is syncing, because the proximity switches are syncing. So that's basically it. And I show that it's, right now I show it's in, I'm using this light to show that it's an cycle. So if I hit the cycle stop as it's running, see the cycle light goes out, it completes its cycle and then stops. So that's basically a little bit, but main thing I wanted to show is that all the circuit boards are built through gel PCB. I designed it from the beginning to the end, and all the way through the design of each of the boards that you see. There's 7 different boards that you can put on this motherboard, and operating this microcontroller, or interfacing to the microcontroller. So you're having 24 volts DC sink or source, and you have AC 120 volt output or 120 volt input that you can connect to this board to operate the microcontroller. So thank you for taking a look at it, and if you have any questions, please let me know. Bye now.